This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Topic 11. You finished Week 3 heat transfer. 11 decks, every formula handbook indexed, every problem type worked. This video is how to use it, where to spend your final study days, how to navigate Chapter 5 at speed, the traps that repeat across the 3 modes, and the time budget that finishes with margin. The priority matrix. Very high yield, conduction fundamentals, thermal resistance networks, convection fundamentals. High yield, cylindrical and spherical conduction, forced convection correlations, heat exchangers. Those 6 are about 70% of the exam. Medium yield, transient conduction, fins, natural convection, radiation. Only after you own the 6. 1 weekend left, spend it on topics 01, 02, 06, 03, 07, and 10. What changes from Week 2? Heat transfer is resistance network heavy. Most problems start with a thermal circuit of series and parallel resistors, before any algebra. Property temperature matters more. Convection at the film temperature, radiation at absolute temperature, Kelvin or Rankine, never Celsius. One chapter dominates, Chapter 5. A single problem can chain all 3 modes, so identify the dominant one first. And the Reynolds-Prandtl-Nusselt triad replaces the Moody chart. Pick the Nusselt correlation by geometry and flow regime. Navigation. Set these Chapter 5 bookmarks in your first 60 seconds. Left column, conduction and transient. Fourier's law, conductivity, plane wall, cylindrical and spherical, the resistance network, the Biot number and lumped capacitance, transient charts, fins. Right column, convection through radiation, Newton's law of cooling, external flow Nusselt correlations, internal flow Dittus-Boelter, natural convection, heat exchangers, Stefan Boltzmann, radiation exchange. About 16 bookmarks. Practice until it takes under a minute. The 10-second rule. Open the search bar, type 1 keyword, Fourier, resistance, Biot, lumped, fin, Newton, Nusselt, Dittus, Rayleigh, LMTD, NTU, emissivity, view factor. If the formula doesn't surface in 10 seconds, skip, flag, and return in pass 2. Don't dig, don't scroll. Most students lose more points to slow navigation than to physics. Make search a reflex. And handbook first, memory second. Don't memorize the correlations or property tables. Know where they live. Trap compendium. Topics 1 through 4. Conduction. Keep the area and sign in Fourier's law. And read conductivity at the mean wall temperature, not room. Resistance networks. Series add. Parallel add as reciprocals. Draw the circuit first, and include the convection resistance at each surface. Cylindrical. A pipe needs the natural log resistance, not the plane wall form. And watch the critical radius, below which insulation increases heat loss. Transient. Check Biot first. Above 0.1, lumped capacitance fails. Use the charts. And don't mix the characteristic lengths in Biot and the chart axis. Trap compendium. Topics 5 through 8. Fins efficiency compares to an isothermal fin. Effectiveness to no fin at all. Don't swap them, and use the fin tip condition the problem describes. Convection, properties at the film temperature, and the coefficient comes from a Nusselt correlation, not a table. Forced convection. Match the correlation to the geometry. External differs from internal pipe flow, and use Dittus-Boelter only for turbulent, fully developed flow. Natural convection. Buoyancy uses Grashof and Rayleigh, not Reynolds, and beta is 1 over the absolute film temperature. Trap compendium, topics 9 and 10. Radiation. Stefan Boltzmann is absolute temperature to the 4th power, Kelvin or Rankine, never Celsius. And keep the surroundings term, since a surface radiates and receives. Emissivity of 1 is a blackbody idealization, not a default. Real exchange needs the view factor and surface emissivities. Heat exchangers. Use the log mean, not the arithmetic mean, which overpredicts when the difference varies. Pair the differences correctly by flow arrangement. And if an outlet is unknown, you cannot use LMTD. That's the effectiveness NTU case. Time budget. 80 questions over 480 minutes. 6 minutes each. Heat transfer is roughly 10 to 15% of the TFS exam, about 1 hour total. First pass at 4.5 minutes. Commit the easy ones, a plain wall or Newton's cooling. Skip and flag the long dig or trap-prone ones, a Nusselt lookup or a combined mode network. Second pass, flagged questions at 6 to 8 minutes each. Last 20 minutes. Review flagged. Change an answer only with specific evidence of an error. Never leave blanks. Eliminate 2 and guess. Hard limit over 8 minutes on one question. Flag and move on. Not moving on is how people run out of time. Per question rhythm, 6 beats. Read the problem once, fully. Identify the dominant mode, conduction, convection, radiation, or combination. It selects the heat rate form. Sketch the thermal resistance network, every surface and layer. Build the variable table, quantity, value, source, and each property's temperature. Solve using the framework. Fourier, Newton's cooling, Stefan Boltzmann, LMTD, don't improvise. Sanity check in 20 seconds. Unit stack, properties at the right temperature, biot before lumps capacitance, heat hot to cold, efficiency or effectiveness between 0 and 1. If any check fails, flag and return. 24-hour review. Night before, no new material. Skim the priority matrix to confirm topics 01, 02, and 06, feel warm. Rewatch the trap slides for thermal resistance, convection, and radiation if rusty. Lay out your ID and NCEES approved calculator, layered clothing, a snack, and water. 8 hours of sleep, 2 alarms. Morning of, breakfast with protein and complex carbs. 10-minute handbook drill. Search 5 random keywords, practice the 10-second rule. Rehearse session 1's first 60 seconds, setting your chapter 5 bookmarks. Arrive 30 minutes early. During the break, water, walk, don't cram. Session 2 is a new exam. Week 3 recap. 8 things you now own. The 4-beat structure. Concept, setup, solve, traps. Mode identification first. Conduction, convection, or radiation. The thermal resistance network as the first sketch. The variable table framework. Handbook bookmarks across Chapter 5. The property temperature discipline. Film for convection. Absolute for radiation. Trap categories across all 11 topics. And the time budget. 6 minutes per question, never more than 8. Next, Week 4, HVAC and refrigeration. Same structure and framework. New physics, psychrometrics, the vapor compression cycle, cooling and heating loads, ducts and fans. Thanks for completing Week 3. If it helped, please subscribe.
The full study guide, with every equation and common exam trap, is free at peprepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.